Okay, so today is 24th March, 9:47 a.m. right now, and I have an interview later. So I actually ran out of easy questions to do on Blind 75 because I finished. Oh, I have one, but uh that's a bit manipulation. I don't really want to do that. I will just be doing a medium. Yes. So this question, maximum product subarray. I need to check what topic falls under. Array and likely one-dimensional DP. So, given an array integer array nums, find a subarray that has the largest product within the array and return it. A subarray is a contiguous non-empty sequence of elements within the array. Okay. You can assume the output will fit into a 32-bit integer. Okay. Cool. So it'll go from -10 to 10. So we do have negative numbers involved. So I think one thing that off the top of my head that I can notice is that two negatives equals to one positive. So actually all even numbers of negatives equals to one positive. Yeah. So let's take a look. You should aim for a solution with O(n) time and O1 space. Okay, so O1 space means I cannot allocate an array to do like prefix array. Yeah, so this is gonna be something different. I would just say that. Okay, so over here, 1 times 2, okay, and -3. Yeah, so actually for most of these like subarray questions, most subarray questions, brute force is O(n) squared because we need to uh check every subarray. Okay. Try to identify a pattern by finding the maximum product of an array with two elements. Okay. Then determining what values are needed when increasing the array size to 3. Perhaps you only need two values when introducing a new element. I think I need to check the number of negatives. Okay, turns out I was wrong. We maintain both the minimum and maximum product values and update them when introducing a new element by considering three cases. Starting a new subarray, multiplying with the previous max product, or multiplying with the previous min product. The max product is updated to the maximum of these three, while the min product is updated to the minimum. Kadane's algorithm. I used this before in the maximum subarray. Ooh, let's do it. Okay, let's go back. So this can use Kadane's algorithm again. Okay, so if nums dot length is equals to 1, we'll just return nums 0. This is basic. So for Kadane's algorithm, let me just open it in another tab just to reference. Let running sum. So we'll need to track three, right? In this case, let running min, because the number will only grow, right? Unless there's a zero. Running minimum is equals to check infinity value or in max in JS. Max save integer. Okay, equals to math dot max save integer. Do, 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 do. Okay. Max value. Or we just call it max. Probably have to use max save integer and min save integer. Undefined. Okay. Number, not math. Let running max is equals to number dot min save integer. Running max. Let's check. Okay, good. Starting a new subarray. So let running value equals to 0, equals to 1. So of course multiplication, right? We need to do it with 1. Maybe this is not a good idea. I'll just not X smart. Okay, we maintain both the minimum and maximum product values and update them when introducing a new element. Starting a new subarray is moving this. So nums I, okay. Then multiplying with the previous max product or multiplying with the previous min product. So for I already instantiated I less than dot length plus I'll do so here let global max goes to number dot uh min save integer. Okay. So if running val, okay, running val is equals to nums I. Okay. So we will always try to multiply. If running val is less than running min, then we will set running min equals to running. Sorry. Running min equals to running val. Okay. If running val is greater than running max, we will do running max is equals to running val times equals nums I equals to 1. Okay. Anything multiplied by 1 gives you back the original value. So if it's bigger, I'll do running val. Okay. I just start with 1 lah. Yep. So eh, yeah. Doot, 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 doot. Oh, this one is just I can just do number dot max. Yeah, this is correct. Because what I want to do is to always trigger something to change. So in this case, right, if I take 1 times the first number, it will most likely, if the number is positive, it will update min to that number, but max will not be updated to that number. Oh no, you'll update. It will update, all right. Because 1 is smaller than this, the max integer, and 1 is also bigger than the negative integer. Okay, then you update both first pass. Then I'll do if do 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 if running val. So we start. Okay, then it goes to 2, then 1 times 2. Is it bigger than the minimum? Is it smaller than minimum? No. Is it bigger than the maximum? Yes. So I update. So do I start a new array? No. Starting a new subarray. Oh, case 1. Start new subarray for nums I. Case 2. Multiply previous max. Case 3. Multiply with previous min for negative numbers. So let const case 1 is equals to nums I. Okay. case 2 is equals to nums I nums I multiplied by running max. Case const case 3 multiplied by running thing. Okay. Running max is equals to math.max case 1, case 2, case 3. Running min math.max case 1, case 2, case 3. Dot running min. Oh, return. Oof. Ah, okay. So if running max greater than global max, update global max. So global max is equal to running max. Oh, sorry. Woof. Well, I cheated. So let's run through why this works. Okay. So for most subarray questions, the brute force solution is O(n) square because we need to check every subarray. All right. So nums.length is equals to 1, you return the first number. So we keep global max being the minimum number, uh, the minimum representable number, so that any number will be bigger than it. So we'll at least get the maximum number instead of a product. Okay. Next, running min is equals to 1 because anything times 1 is itself. And running max is also 1 because anything times 1 is also itself. Then we let I equals to 0. So, I mean, I can just remove this and I'll make the code a bit neater. So we let I equals to 0. We iterate through the array using Kadane's algorithm again. So O(n) time O1 space is Kadane's algorithm. Okay, so you either start a new array from nums I. Okay, so if this number is bigger than the running max previously, right, then we'll just take this number. So in this case, let's just run through for 1, 2, 3, 4 how it goes. Okay, so index 0 is 1. So case 1 is 1, 1 times 1, and 1 times 1. So running max and running min are both 1, and the global max becomes 1. So I can just console.log running max, running min, global max. Okay, I'll get 1, 1, 1. Okay, cool. So next one, 2, 2 times 1, 2 times 1. So the same thing, running max will become 2, global max becomes 2, and running min becomes 2 because it's a minimum. Okay, next, minus 3. So minus 3 is the number itself. So if I were to start from this subarray, right, and it's so meaning this number is bigger than everything so far. So far. So case 2, running max. Case 3, running min. Okay. So in this case, minus 3, this one is minus 3 times 2, minus 3 times 2. Right. So running max becomes minus 3. Right. So Sorry, running max becomes running max becomes the maximum of all this, which is -3 -6 -6. So it becomes -3. Okay. So is -3 bigger than 2? No. So it's still 6 and 2. Global max is still 2. All right. Running min becomes -6 in this event because if let's say there's another negative number that comes out, running min will take care of it. Running max will make sure that if there's another positive number, we get something out of it. So running max so far is -3. Then we have no choice but to keep it. Okay? So got me so far. So for running max, right, you will never want to consider this two. You want to start from here. Okay? So next question. The last one. 4. 4 times running max is -3, right? Yeah, so this is -3 previously. Then this is 4 times -6. So case 1 will be 4. Case 2 will be -12. Case 3 will be -24. Running max will become 4 because it's the biggest one. All right. So running max at that point 4 is bigger than 2. So we will set round global max to be 4. Running min still -24. So it's 4 -24 and 4. So the answer is 4. So we do another case. Nah, I think should be quite straightforward, right? So for this case, it's two negative numbers. So first round is all -2, right? So your running max, running min, global max is all -2. The next case, all right, -1, -1 times -2, okay, -1 times -2, okay? So running max becomes the maximum of all this, which is 2, because you either use -1 or 2 here, okay? Then running max will be set to global max because it's bigger, right? Because previously it was -2, now it's 2. Then for running min, we'll keep the value of -1. Why is it -1? Oh, because I get -1, 2, and 2. So the minimum is -1. Okay, fair enough. So I'll submit this again. Perfect. And yeah, that's pretty much it from me. About 20 over minutes just to do one question, and I'm done for the day. Goodbye.